Good afternoon.
Jacob, are you there? Hello?
Yeah, can you hear me?
Yes, can you hear me?
I
Jacob?
can. There seems to be a slight lag between your video and your voice.
Well, I don't know. Hang on a second. Da-da-da. Well, coming. That's lovely.
How are you doing otherwise?
Pretty good. I'm seeing your name. I'm not seeing your screen. I'm not sure what to do.
Well, I'll start sharing my screen. How's that?
Okay, try to show your screen. See what happens.
Oh, it says that I can't share it while you're still sharing.
Oh, am I supposed to unshare?
Yeah, go ahead and stop sharing and I'll try sharing.
Well, okay. New share. Do what?
The red button.
Oh, stop share. Oh. I warn you, I know not much about what I do in here. There you, hey.
Did it work?
What a good looking group.
All righty. Good deal. Can you all hear me okay?
Just a second. I've got issues we're on my little computer. All I know to do is to try to get it closer. You guys may need to huddle up here. Okay, start talking and turn whatever volume let me see here. Do I have more volume? I don't know.
Testing. 1, 2, 4, 8, 15, something.
Speakers. Help. Back out, pause. Well, as far as I can tell, I think I've got the volume on the computer up as high as what is it? Keeps disappearing down here. I don't know. Can you guys scoot up a little bit and maybe hear Jacob?
I'll send all this information to you as well. But I wanted to kind of give a brief overview of Eastman and then kind of discuss what I'm hoping, give a little bit of background on the project, and then talk it through with y'all, see what initial ideas you guys have, answer any questions you might have, and then kind of talk about what some of the deliverables might could be at the end of this. If that sounds good?
Yeah, just we work on this volume for a second here. I can't hear you. Well, I don't know. There's speakers in this stupid cabinet that Lord knows what it's going to take to make this work. I mean, look, there's a rabbit's nest of wires down there. Hang on, Jacob. Give us a few here.
Okay, no problem.
We've got speakers. It's just a question of trying to get them hooked into my system. This other system didn't seem to like it was going to be working. I don't know.
Okay.
We're working on it.
Sounds good.
That might be. Okay. Try it again. Hello?
Hello. Testing. 1, 2, 4.
Ah, we are there. Yeah, just set them up there.
All righty.
Good work. Okay, we're getting close. Now we just got to get everybody back in their seat and all that stuff.
Sounds good.
Okay, is everybody good? Is everybody ready? You look this way, I can tell. Okay, go ahead, Jacob.
All righty. Well, good afternoon. My name is Jacob Bubalo. I'm an engineer, HVAC and facilities engineer with Eastman Chemical Company based out of Kingsport, Tennessee. I've been with Eastman just over 3 years now. I joined right out of school. I graduated technically with a civil engineering degree from Purdue, but work primarily as a mechanical engineer. I figured my plan for this afternoon is to kind of give a brief overview of Eastman as kind of an introduction to what we're doing. Talk a little bit about the project, give some history and background on it. Introduce y'all to our control system, and then kind of work through the project parameters and what I'm hoping to get out of it at the end, and then talk through some of the general ideas with y'all, and then kind of wrap up and see what questions you guys might have. If you have any questions at any point, please feel free to interrupt. And if at any point my screen disappears, let me know. My computer sometimes has better days than others, so we'll give it a shot. Alrighty, kind of a real brief overview of Eastman. We're a global specialty chemicals and plastics manufacturing company. We've got a number of employees at quite a few sites around the world, and we kind of some of the things that are more relevant to this project are that we've been an Energy Star Partner of the Year for 7 years in a row, which is going to come into play a little bit later on. But our 2017 sales revenue of $9.5 billion. You won't necessarily see Eastman's name on the shelf, but you will see our products out there. So, for example, we've got a lot of tire additives in vehicle tires. We've got quite a few products in performance films, whether it be paint protection film or acoustic interlayers to kind of deaden some of the road noise. We have a lot of additives in paints, inks, adhesives, coatings, and then all the BPA-free plastic and Camelback and Nalgene water bottles. That's all our product as well. But one of the big things, and if y'all are able to come and make a trip on site, one of our key focuses is all in for safety. I serve as our division safety coordinator, and so what this means to me is it's all about making safety personal. Why do I stay safe at work? Whether it be so my parents don't get the call that, hey, Jacob was injured while at work, or we've had a really bad day at work today, someone got injured or worse. But and however y'all choose to approach or tackle the project, safety has definitely got to be one of the things that you keep as your top priority, especially when you think about implementation of your solution. How are you going to do it safely while the building continues to be occupied? But what I always tell all the folks in my division is that I want you to go home better than when you came to work, because I want you to come back to work the next day. But again, kind of going forward with the Energy Star Partner of the Year and Eastman, we've been Energy Star Partner of the Year 7 years in a row, and that's tied not only to having our buildings Energy Star certified, but also to a lot of the new and ongoing initiatives, of which this is one. Partnering with universities to help us solve and work on our energy use is something that I really enjoy, and I think it's something kind of unique that we can put on our application, especially for a chemicals manufacturing company. Personally, I really enjoy working with you guys, and have in the past, just because you guys bring so many different ideas and so ask really great questions that sometimes I forget about, and just kind of make assumptions that when you ask the question, it forces me to stop and reconsider. Well, that's a great question. I have no idea why we do it that way. And that was the way that someone told me we did it, and I haven't stopped to think about it. So please ask questions and help me out. Let's challenge what I guess my assumptions are. But just a Google Maps view, this is our entire Kingsport manufacturing site. Everything. Can you guys see my mouse okay?
Yeah.
Okay. That's all part of the manufacturing site there. This is our corporate headquarters building, our new one, and this is our old one right here. And that's where we'll be focusing this semester, is kind of working on that one there. But as far as career opportunities, you could, as an engineer, you'd have an opportunity to work in any of these different groups and departments. And whatever our solution is going to have to involve just about every single one of these, from the business world, plant protection, environmental affairs, especially with discharge, any sort of discharge coming out of it. Obviously, all the other engineering groups, the energy management team, procurement, manufacturing. Legal's not on here, but they sit in this building, and so we have to keep them happy. That's very important. So with that, are there any questions about Eastman?
Guys, any questions? I'm seeing all the heads shake no, so carry on.
Perfect. Okay, so that's the boring part of this. Now for the really exciting part. So Building 280B is our old corporate headquarters building. It's attached to Building 280 core. And so the wings of this building were built in 1993 and are cooled by individual water source heat pumps. Have you guys covered what a water source heat pump is?
Yes, sir. They just took a test
Perfect.
on that.
Well, good. So with that, there are 100% recirculation units, and then each of them has a little bit of dedicated outside air supplied by 100% outside air unit with a desiccant wheel and an enthalpy wheel in it. The individual water source heat pumps are at the end of their life expectancy, and the compressors in them are failing, and we are having a very, very difficult time buying replacement compressors. In that the company who manufactures them, the ones that specifically fit this model, stopped manufacturing them about 5 years ago, and we've bought just about every compressor that's out there. So yeah, as the compressors continue to fail, we're starting to either tear down units or move people out of their offices because we just don't have a way to heat or cool that space anymore. And so what I'm looking for input on from all of you all is, what are my options for replacement, essentially? Is my best option to go back with a like-for-like replacement? In order to do this, all these water source heat pumps are up in the ceiling above the space. So I got to tear out all the cubicles, all my walls, all the movable partitions, all the furniture, all the data and electronics, and all the people's personal stuff, move them out in order to access this. And if I'm going to go through the trouble to do that, would it be more efficient, better for me to put in centralized chill water air handling units? Would it be some other technology, whether it be chilled beams or radiant panels, or install some sort of raised floor system, or whatever else is out there? Yes, no, I certainly vote against the raised floor, but we're laughing because our new corporate headquarters building that you guys were helping out with last year, that has underfloor air distribution, and it is a mess. Which a nice way to put it, I guess. But I'm hoping that whatever solution y'all recommend, and whatever system that we eventually have to go back with, we're able to make it sufficiently energy efficient to a point where we can get the entire building, Building 280B and 280, the entire complex, Energy Star certified. Energy Star recently updated their metrics, the baseline that we compare against, from 2003 to 2012. And so across the board in general, Energy Star scores have dropped pretty far. And so this would be a key building, one that we've got metered and separated out individually to where we can see actual energy changes. We've got 3 or 4 years worth of energy data that we can use as a baseline to see, as we implement new systems, how are we changing it. So with that, this is the building kind of from Google Maps. This is the building here. This center part is the core. That was built in 1970 something or other. It has centralized chill water units in it. Chill water air handling units. It's got 6 of them, and we also have hot water boilers. It's a traditional dual duct system with dual duct terminal units, VAV dual duct terminal units. And just recently, as of this morning, we were about to start up our second we just replaced the chillers to make them more energy efficient and replace chillers that were at their end of life. We purchased magnetic bearing chillers, which are absolutely fascinating. The entire rotating assembly, compressor head, and shaft, and all of that is levitated with electromagnets instead of your traditional oil-based bearings, which reduces the noise, reduces the complexity, and eliminates the problem of walking into the mechanical room and seeing oil spraying out almost every time. So I'm very excited about that. All that to say that we do have a significant amount of chill water available. We have 2 400-ton machines there, and I'm really only running one at maybe 75% right now. So we do have chill water available. I also have 3 natural gas hot water boilers to generate heating hot water at about 180 degrees. So that is another utility that is available. There's also natural gas available on site in the building as well. And then we've got cooling towers across the road. You can kind of see them up here as an option. But specifically, the part of the building that we're working on are these 2 wings here. This is your south wing and your west wing. This atrium space, which includes the front lobby. This is an awning, and then these areas right in here. This wing and this wing are the ones that are supported by individual water source heat pumps. There are about 208 of them in there. This building is 3 floors on each side. The use space in these wings here is primarily office space, individual offices, open cubicle plans, conference rooms, meeting areas, and break areas. The kitchen in this building and the cafeteria are in the core. They're served by the core air handling units. And then you can see these 2 white boxes. Since this was Google Maps took this, they've been painted dark green, but they are your makeup air units, your 100% outside air Munters units with the desiccant wheel and the enthalpy wheel. Any questions so far?
Questions, guys? Now everybody's just watching, taking notes.
Okay. Excellent. But as you can see, there's a fair amount of glass around the perimeter, and they've done quite a bit to open up the interior to where you can actually, to where that daylight will penetrate fairly far into the building. So during the summer, especially in the evenings, the solar load is going to contribute to whatever system is installed, just as a thought. But everybody, Dr. Cunningham should have a copy of these drawings. I apologize for the drawings that aren't set up quite right. We are working on fixing our system to generate the PDFs appropriately. But what you can kind of see from this is this here is a drawing. Oops, I apologize. That shows the kind of the HVAC plan. So what you've got ductwork coming out of your water source heat pump. All these dark black boxes are the individual units themselves. This is just 1 floor of 1 wing. So you've got 5 more of these for 6 in total that look very similar to this. The layout has changed based on kind of some of the arrangement up here for the individual offices versus conference rooms. But you have distribution ductwork coming off of it, and then you have your return coming back. And it is an open plenum common return across the entire space.
Jacob, how does the outside air, how's the ventilation air get in here?
You see this main trunk line right here?
Yeah.
That's coming from our dedicated outside air unit.
Okay.
And then it's hard ducted all the way to the return of every single unit. And then that's also how we achieve humidity control to a certain extent in the space. We try and dry out the air coming in through the makeup air unit down to 15 to 20% relative humidity at 70 degrees.
Yeah, gotcha.
Is that terribly effective? Not particularly. If our system goes down for, say, 3 days, it'll take us 5 days to get our humidity back under control. So not my favorite.
Yeah.
But so this shows the ductwork plan, and accompanying each of those that ductwork plan, you also have a hydronic plan, which shows all of your water lines coming through. So your heat pump supply, heat pump return, it should run to every single unit, and then you also have a drain line shown on the plumbing plan for the condensate pan underneath each one of these units.
Now, what's the condition of the piping? Is the piping still pretty good, or is it not so good?
The piping is in fairly decent condition. They ran copper piping, and it hasn't corroded all that much, which is surprising. Now, the condensate lines, on the other hand, are one goopy mess from slime and stuff that's built up in them. But we've got all different sizes. These are all horizontal heat pumps hung up in the ceiling from the building steel.
Okay, understood.
And then each one of these has its own individual thermostat. And those thermostats should be shown on this drawing here. For example, this THP-5 thermostat for heat pump, the 5-ton heat pump shown over here.
Okay.
So with that, here's a section view of our makeup air unit specifically. Makeup air unit on the roof coming down. And then it's got an exhaust air or relief air stream coming out as well. But it worked. So this is our control system. For this building specifically, just like our last building, we use Metasys by Johnson Controls. And what that allows us to do is it allows us to see each of those spaces in depth. So for example, if we pull up the second floor and pull up the west wing of the second floor, you can see each one of those spaces. So this was a space that was controlled by a heat pump, a 5-ton heat pump. And then we can get all the stats on it, including is the fan running, how's the compressor doing, what is my liquid line temperature, and all of that. So whatever system we go back with is going to tie back into Metasys as well, into our control system, so that we can manage it remotely.
That's nice. That's such a nice system.
It is certainly handy for troubleshooting. Because one of the powerful things about this system is that you can set up trends, so I can see when did the compressor come on, and after my compressor got its command to come on, how long did it take before my discharge air temperature started coming down again, and did it come down? So my compressor is on and my discharge temp is 55 or 53.6, excuse me. So I know my compressor is running. However, what we're seeing quite a bit of is that my compressor command is on, but my discharge air temperature is still 76, which to me says that even though I'm telling the compressor I want it to run, my compressor is not spinning.
It's not doing too
that's
good.
a bad day.
No, it's not doing too good.
Yep. So kind of backtracking back to the overall system, we have a common heat pump loop, and it's just a primary pump system, so it's a primary loop. And there it is. So what's shown in red, this dark red is what's coming back from the building. The heat pump right now, because the outside air temperature is 77.7 and it's overcast. So we're not in an extreme cooling condition right now. So my heat pump loop return is coming back 79 and it's going out to the building at 74. And I run it through a series of plate and frame heat exchangers. I've got 2 of them in parallel. Set up with a condenser water loop going through my cooling tower. This is how I cool my heat pump loop water down. So since these are all water source heat pumps, I've got to they reject their heat to the water, to the heat pump loop, and that in turn rejects its heat out through the cooling tower, through this green loop here. In the winter though, as it starts getting colder, this heat loop heating valve right here will open up and it is connected to our boilers. And so we can take some of our heating hot water and circulate it back into this loop here. In an effort to warm it back up.
You know, these guys had a test last week, and I could swear there were questions like that on that quiz. Does anybody remember that? Nobody's shaking their head, so I don't know. Anyway, go ahead. I didn't mean to interrupt.
But what that allows us to do is that'll allow some of the heat pumps to operate in cooling mode and some of them to operate in heating mode. And what we see is that, especially for kind of the center parts, or the parts closest to the core in the wings, the parts that aren't exposed to the exterior, they seem to run in cooling mode 85% of the year. And so it ends up working out into a fairly decent balance to where I very rarely open up my heating valve in the winter. The heat pumps that are running in cooling mode put enough heat back into the loop to where the ones that are running in or excuse me, the heat pumps running in cooling mode put enough heat back in the loop to where the ones running in heating mode can then take it out without requiring supplemental heat. It's only if our building gets exceptionally cold, or again, if it goes down and needs to play catch up, that we have to put in quite a bit of supplemental heat back into the red heat pump loop shown here. Does that kind of make sense?
Yep, absolutely.
Okay. But the loop itself is controlled with differential pressure, and we've got plenty of capacity left. Each of these is a 200 horsepower pump, and it's only running at 65% to meet loop differential set point. So there is an opportunity there, I think, if you wanted to reuse the system. But we are also in the process of replacing and upgrading the chill water system. And so again, you'll have lots of opportunity, lots of chill water capacity available if you want to switch over to a different style unit, if that becomes an option.
Yeah.
If that's of interest.
Oh,
but
yeah.
The chill water system is set up as a the chill water is set up as a primary secondary loop.
Okay.
And then the only other piece of the wing that's significant, there are some restroom exhaust fans, and then this is the schematic of our makeup air unit for the south wing. This is the return air coming out of the building. It runs through the enthalpy wheel before getting exhausted out through the unit. This is your outside air stream that comes through, goes through an energy recovery. The energy recovery wheel then goes through a solid desiccant wheel, where it goes from 78 all the way up to 101 before running through a cooling coil and trying to drop the discharge air temperature, although the humidity is already low, before it gets discharged into the building. And then here's a reactivation airstream. Comes in at 176, evaporates as much of the moisture as it can out of the desiccant wheel, and ends up coming out at 124.8. And these are pretty typical operating conditions on it.
Okay.
So the makeup air units are in fairly decent condition. We've replaced the wheels, the media and the wheels relatively recently. I think that we could probably get another 10 or 15 years out of them. Okay. But the water source heat pumps are failing, and we're going to have to do something to them. So with all of that background, what I'm hoping for is to get a couple different proposals or just one proposal that y'all are confident or feel like would be a good alternative for the water source heat pump replacements throughout the building. And that, again, could include just a straight like-for-like replacement. If that's my best option, that's my best option. But at least we've looked into it. Or it could be switching over to chill water units, large air handling units, some sort of centralized system, decentralizing it. I have no idea what's out there. Chill beams, something. But I'd like the proposal to include a rough scope of work. So what all is going to be involved with this, both mechanically, electrically, structurally, and then if there are environmental considerations we need to look at. Kind of a ballpark cost estimate. This would be a plus or minus 50% type deal, and we're looking at a $5 million job, a $500,000 job, a $50 million job. Where's it going to fall? If you guys are going to change the sequence of operations, if you're going to put in something large, help me think about that and what you'd recommend. And then also, it'd be great to think about kind of the construction schedule and logistics. So since this is a fully occupied building that's got people working in it, you're actually 7 days a week. So the people on the nights and weekends are limited enough that we could relocate them. But if I'm going to need to relocate a whole wing at a time, I got to find a new building to put them in or something. We put up some temporary structures, do something to them. So it'd be good to know how you guys would sequence this or stage it. So kind of think about the overall project as a whole. And then if you're interested or have anybody who's interested, kind of take a look at the energy modeling, and I can find some baseline data and then compare and see what are the energy efficiencies gained by putting in a new system or by your proposal.
Okay, we're definitely interested in the energy simulation. We'll have to run loads on the building, and once we run loads, you have most of what you need to go ahead and run energy simulations. So
perfect.
That part shouldn't be a problem.
Okay. Then And for the construction schedule and logistics and kind of some of the cost estimate, that would just be something to kind of consider as a pro or a con of each of the different proposals as you evaluate them. What's it going to take, and is it reasonable, and what is your recommendation on that?
Okay. Super.
Okay.
Okay. Let's talk about a couple other things. I've got 20 people plus myself in this classroom. We need to get up there. And of course, you know, traveling during the week is tough. Would you entertain a visit on Saturday?
Yeah, I think so. I need to coordinate, and we need to work out some logistics, but I could make that work.
Okay. I mean, I've not talked to the group. This is all, they didn't know this was coming. I mean, I had mentioned Eastman, but, you know, I've been out of town, and they had a test last week, and this, that, and the other. And so this is, talk about a major dump. This is a major dump on the class, but, you know, that's what life's all about, isn't it? I think so.
I apologize. I'm very sorry.
No, it's on me, not on you. No. I just, you know, but once I realized that we were going to do this, I felt like, well, we need to get this information on the table as quick as possible. And for everybody in the classroom, this presentation is being recorded, and so this will be available on YouTube. Jacob, do you consider this proprietary? Do you want me to make it private or public on YouTube?
If you can make it private, I think that'd probably be the best option, but the information I'm sending you can be distributed with your class. That's no problem.
Yeah, no, that's fine. When you upload a video, you can make it public or private. I'll just make it private and then email out the link to everybody, and I'll send it to you too. So if you want to hear yourself regurgitating this, you can at any point you want. You know?
No, thank you though.
Okay, so point one, we need to get up there, and I think a Saturday, I mean, I don't know how many, we haven't polled people, but I trust I can get more people up there on Saturday than I can during the week. Because, you know, people got classes, this, that, and the other. And so that would be my intent. The other thing that comes to mind, there's a fellow, Chris Loftus, who works at Smith Seckman Reed in Nashville. Chris came out of the TTU, and I'm good buddies with him. And, you know, Smith Seckman Reed's kind of big time firm. And I think I'm going to see if I can get Chris to review this information, and maybe he'll come here, or we'll do, you know, a video conference like this with Chris, and get him to run through possible systems that they would consider at SSR if this was one of their projects. You know, just to kind of make sure that we touch the bases. And then I will contact Ken Stone again, my local contractor buddy, and see if Ken is willing to be involved in terms of, Ken keeps us on the rails in terms of cost, you know, what's it really going to cost to put in this kind of a system, and, you know, the logistics and actually getting something accomplished in the building. I mean, that's what Ken does and has done for, you know, 25 years. You met him, and he's a really good guy. So
that sounds great.
I don't know if he'll be willing to work with us again, but I kind of suspect he will. He's pretty good buddy. So I don't know. Does anybody else have anything on the top of their head that they want to throw on the table here? I'm not seeing much. I've had paper copies made of those two files that you sent. I have 11 copies. One I'll probably keep for myself, and then I've got 20 students and 10 other copies. So they'll probably get to share a set between them. But I think it's good to have paper copies. You can get lost in those PDFs, you know, just looking
absolutely
electronically. So those are on the table. We'll give those out after we get finished here. And I guess you need to look at your calendar, and I'll look at mine. I'll talk to the group, and let's pick a couple of Saturdays as soon as possible. I can get a 15-passenger van, and beyond that, if more can go, somebody will have to drive, and, you know, they can be reimbursed by the university. There's no problem with that. So I guess I think that's all I got off the top of my head here. Jacob, you got anything else?
Nope, other than I really appreciate you guys taking a look at this, and I'm excited to see what you come up with. VRF might be another option for it.
Yeah, I was thinking about that.
And maybe that's the direction we go. Honestly, I have no idea. The sky's the limit with this. That's about it.
Okay. Well, we'll go ahead and sign off if I can figure out how. And, I guess you need to stop sharing, I think. Ah, there. I can see my own face, and that's a pretty scary thing. Okay, Jacob, thanks very much, and we will be back in touch.
All righty. I look forward to it. Thank you.
Okay, bye-bye.